Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Applications of ratios, rates, and proportions. This video will help you interpret a scale drawing, use a sampling method, compare a prescription dose to the usual dose, and determine how much medication to give. Interpret a scale drawing. Scale drawings are used to design buildings, ships, mechanical parts, cars, etc. Let's take a look at some definitions. A blueprint is a scale or proportional drawing. The scale on a blueprint describes how the dimensions of the drawing relate to the actual object. Now let's take a look at an example that will help you understand how to use a scale drawing to determine measurement in the actual object. Example 1. Measuring from south to north, what is the width of this living room? Before we take a look at the width of the living room, let's notice the scale on this drawing. And we're going to write this scale 1 inch over 5 feet. It tells us that 1 inch in the scale drawing represents 5 feet in this actual living room. We're going to use this and we're going to write it in a proportion. Now let's take a look at the living room, measuring from south to north. So we're going to start over here at the south and we're going to count our way across this living room. So there's 1 inch, 2 inches, 3 inches, 4 inches. So it looks like 5 inches. So we're going to write down here in our proportion 5 inches. And we want to know how many feet that's going to be in the actual, in this case, a log cabin, the actual width of the living room in the log cabin. So now we have a proportion and we can solve this. Notice the variable n is in the denominator, so we're going to flip both sides of this proportion. So we have 5 over 1 on the left side is going to be equal to n over 5 on the right side. You can see that we're on you can see the variable is being divided by 5. So we want to undo that. To undo that, we're going to multiply by 5 over 1. Do the same thing on the left side. 5 over 1. On the right side, you can see the common factors of 5 dividing out, leaving us n over 1, or just n. And on the left side, it looks like we have 5 times 5, which is 25, and that's going to be feet, because in the actual log cabin, that's going to be 25 feet. Now it's time to check your understanding of using a scale drawing to determine the actual length of an object. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 1. Measuring from east to west, what is the length of the living room? Well, again, let's start with the scale drawing. The scale on the drawing. 1 inch equals 5 feet. Okay, now measuring from east to west in the living room. So starting across the living room, looks like we're going to go 1 inch, 2 inches, 3 inches, 3.5 inches. So it looks like in the scale drawing we have 3.5 inches. And we want to know how many feet that's going to be on the actual living room of this cabin. Okay, so again we have the variable in the denominator, so we want to flip both sides of this proportion. So we're going to have 5 over 1 is equal to n over 3.5. Well, we want to get rid of the division of 3.5, so we're going to multiply by 3.5. So this side we'll take 3.5 and multiply over 1. On this left side, we're going to want to multiply 3.5. We don't want to write that over 1, though. We're just going to write it as 3.5. Now on the right side, you can see this common factor of 3.5 dividing out. Now on the left side, we got a little bit of work to do. We're multiplying 3.5 times 5 over 1. Remember that we don't multiply with mixed numbers, so we need to turn that 3.5 into an improper fraction. So remember to do that. We work in a circle. First we multiply. 2 times 3 is 6, then we add it to the top, and so that's going to be 6 plus 1 is 7, so it looks like 7 halves when we turn 3.5 into an improper fraction. So let's rewrite this again. So we're going to have 7 halves times 5 over 1, and that's going to be equal to n. Well, let's see. All of those numbers are prime, So we're not going to have any common factors divide out. So it looks like what we're going to get is we're going to get 35 over 2. Well, 35 over 2 is not a good dimension. We don't want to tell somebody to build a cabin 35 over 2. So we're actually going to divide that 2 into 35. 2 will go into 35 17 times with 1 left over. So it looks like 17 and a half feet. So we're going to get 17 and a half feet is equal to the actual length or actual width of that living room. Use a sampling method. Sampling methods are used to estimate information about a larger group or population. When sampling a population, information is gathered from a small group called a sample. This information is then extended to the entire population using a proportion. 3 steps are typically used to sample a population. Step 1. A question is asked about a population. Step 2. A small group is sampled with this question to establish a rate. Step 3. This rate is then applied to the entire population using a proportion. Now let's take a look at an example that will help you understand how to use a sample to get an estimate about an entire population. Example 2. There are 4,500 students on a college campus. A pollster found that 120 out of 300 students take night classes. Approximately how many students take night classes at this campus? Well, let's start with our sample. It looks like we had 120 students out of 300. There's our sample. We want to extend this now using a proportion to the entire population. Well, notice that 300 was the total number of students sampled, so that has to go along with the total number of students on campus. And in the top, we're going to have 120 take night classes, and on the other side, our variable n, when we solve for that, will tell us approximately how many students on this campus take night classes. Okay? So we need to solve this proportion. We need to get rid of the division of 4,500. So I multiply this side by 4,500. Same thing to the other side. Let's take a look at the right side. That's the easy side. Looks like common factor of 4,500 is going to divide out, leave us with just n over 1, which is equal to n. Left side, we got a little bit of work to do, but I think we can make this a little bit easier. 4,500, if we factor this all out, that would take too long. So what we're going to do is we're going to look to divide out a factor of 300 somewhere in the top. And I look at that 4,500, and I know that 3 times 15 would give me 45. So that tells me that there's going to be a factor of 300 in there. If we took 300 over here on the left side, 300 times 15, that is going to give me that 4,500. And we still have 120 up here, and now we have in the bottom 1 and 300. Now it makes it easy to see that we're going to be able to divide out that common factor of 300. So we divide out that common factor of 300, and it looks like all we have left to do is multiply that 15 times that 120. So on some scratch work, we're going to take 15 times 120, and so 5 times 0 is 0, 5 times 2 is 10, carry the 1, 5 times 1 is 5, plus 1 is 6. Then when I multiply by 1, I'm going to get 0, 2, 1. Add that together, 0, 0, 8, 1. So it looks like we're going to get 1,800. Now let's answer the question they asked. How many students take night classes on this campus? So it looks like 1,800 students take night classes. Now it's time to check your understanding of using a sample to get an estimate in an entire population. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 2. A biologist watched salmon swimming upstream. She estimates that 40 fish swam by her in 3 minutes. Approximately how many fish will swim by her in a 24-hour period? Okay, well, let's start with that sample. So it looks like 40 fish in 3 minutes. And we want to use that now to make a prediction about a 24-hour period. Well, notice 24 hours is not the same unit of measure as minutes. So we need to come up with a number of minutes there for this sample. So we need to turn 24 hours into minutes. Well, there are 60 minutes in an hour. So the first thing we're going to need to do is we're going to need to come off on some scratch paper and multiply 24 times 60. So let's see, 4 times 0 is 0, 6 times 4 is 24. We go through and multiply by 2. 2 times 0 is 0, 2 times 6 is 12. So 0, 4, 4, 1. So it looks like there are 1,440 minutes in 24-hour period. Now, we're going to use that number of minutes to figure out how many fish. Okay, looks like our variable is already in the numerator, so we're set there. But let's not write this with all these units in there. So we're going to have 40 is to 3 as n is to 1440. To get n all by itself, we're going to multiply both sides by 1440. Okay. The only factor we have in the bottom is that 3. So we're going to see if we can divide a 3 out of the top. Well, I can't divide a 3 out of 40 because it doesn't go in there evenly. So what I'm hoping is that 3 will divide into 1440 evenly. So on some scratch work, we're going to check to see if 3 will go into 1440 evenly. So let's come over here on some scratch work. See if 3 will go in there. So it will go into 14 4 times. That's 12. 2, 24. 3 will go into 24 8 times. 24 exactly. Bring down the 0. 3 is going to go into 0 0 times. So it will go in there 480 times exactly. So what that tells me is over here when I'm factoring, what I have then is I have 3 times 480 times 40 in the top, and 1 times 3 in the denominator, and on the right side. Now those 3's will divide out, and all I have to do to figure out how many fish are swimming upstream is to multiply 480 times 40. So again, we'll come over here on some scratch work. We're going to do 480 times 40, 0, 0, 0, and we go through and multiply by 4, we get 0. 32, carry the 3. 16 plus 3 is 19. So it looks like you get 19200. So it looks like 19,200 fish are going to be swimming upstream in this particular river. Compare a prescription dose to the usual dose. Before giving medication to patients, 2 important questions must be answered. 1, is the prescribed dose safe? And 2, what volume of medication must be given? Failure to answer either question accurately can result in illness or even death of a patient. Because these questions are so important, many nursing programs have a gateway exam where students need to score 100% on the exam to pass the course. How to read the label on a prescription bottle. Here we have circled the usual dose on a bottle of medication. The usual dose is the rate that indicates the appropriate dose for a patient. This bottle's usual dose for a child is 20 milligrams per 1 kilogram, which indicates that the child should receive 20 milligrams times their weight in kilograms each day. Now let's take a look at an example that will help you understand how to determine if a prescribed dose of medication is safe. Example 3. A prescription for a 15 kilogram child reads Maychlor, 300 milligrams, given twice daily. Should the drug be given at this dose? Well, we want to compare this dose that's written on the prescription here with the usual dose of the medication. Here's the usual dose of the medication, 20 milligrams per 1 kilogram. So we want to write that down. 20 milligrams per 1 kilogram. Now in this case we have a 15 kilogram child. So let's come over here and using the usual dose, see what amount of medication is usually prescribed. So this is a 15 kilogram child, and we want to know how much medication we usually would give a child like this. Well, let's rewrite this without the units on there. It'll make it easier. 20 over 1 equals n over 15. Okay? Now, we want to multiply both sides by 15 over 1 to get n all by itself. Right side, the 15's divide out, leaving us with just n. On the left side, it looks like we got to take 15 times 20. So we'll come off on some scratch work. 15 times 20, multiply by 0. Now we'll go through and multiply by 2. That's 10. Carry the 1. 2 times 1 is 2, plus 1 is 3. So it looks like we're going to get 300 milligrams for this 15 kilogram child. Now notice in the usual dose it says that this 300 milligrams is in divided, should be given in divided doses, which means we would split this 300 milligrams maybe into 100 and 200, or most likely probably 150 and 150 milligrams. Now let's compare that back to this prescription we had. In the prescription we had a 15 kilogram child getting 300 milligrams twice daily, which means they're getting that 300 milligrams twice in one day. That is twice the amount of medication they're supposed to get. They're supposed to get 300 milligrams maximum in one day. So this prescription right here is not safe, and it should not be administered to this child. Now it's time to check your understanding to determine if a prescribed dose of medication is safe to give. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 3. A prescription for a 5 kilogram child reads Riped 200, 100 milligrams twice daily. Should the drug be given at this dose? Well, let's take a look at the usual dose. You'll notice in the usual dose here we have a range, anywhere from 33 milligrams per kilogram all the way up to 50 milligrams per kilogram. So we actually need to come up with two proportions here to check the low end of things and also to check the high end of things. The first one, we had 33 milligrams per 1 kilogram, and we want to check that with our 5 kilogram child. So we have our 5 kilogram child here. We had 33 milligrams per 1 kilogram, and that's our 5 kilogram child. Figure out how much medication to give on the low end. Well, if we take a look here, n is not all alone. It's being divided by 5, so we're going to multiply by 5 to undo this. So we need to take, on the right side, the 5s are going to divide out and leave us with our n, milligrams. On the left side now, it looks like we need to take 5 times 33. So over here on some scratch work, take 33 times 5. 5 times 3 is 15, carry the 1. 5 times 3 is 15, plus 1 is 16. So it looks like on the low side of things, we want to give 165 milligrams per day. And that's in divided doses, so we would divide that 165 up into a couple of doses. Now let's check the high end of things, 50 milligrams per kilogram. And again, we're still working with our 5 kilogram child in this problem. Okay, so again, we're going to multiply by 5 over 1 to get n all alone. On the right side, the 5's divide out, leave us with n. On the left side, it looks like we're going to take 5 times 50. Well, 5 times 5 is 25, so 5 times 50 is 250. Okay, so it looks like on the low side of things, we could prescribe 165 milligrams to this child. On the high side of things, we can prescribe 250 milligrams. Let's look at the actual prescription. The prescription was for 100 milligrams twice daily. Well, if you give 100 milligrams twice in one day, that's 200 milligrams. That is inside of our range here, so we would say yes, it is safe to give the medication. Determine how much medication to give. After determining that a prescribed dose is safe, the correct amount of medicine must be given. If the medicine is in liquid form, only part of the medicine is the actual drug. The drug concentration is a rate that indicates the amount of drug in a volume of medicine. the drug concentration can be found on the medication label. How to read the label on a prescription bottle. The drug concentration. For every volume of medication, only part of that volume is actual drug, and the drug concentration is the rate that indicates the amount of drug in a volume of medicine. Once we know the drug concentration, we can write a proportion to find the volume of medicine that must be given to a patient. So you see here on this label, here is our drug concentration, and this tells us that there are 375 milligrams of actual drug in 5 milliliters of solution. So we're going to use this drug concentration in a proportion, and then over here on the other side of our proportion we would put the amount of drug that the doctor wants to prescribe up here in the numerator of this proportion, and then we would solve for the volume of medication that must be administered. Now let's take a look at an example that will help you understand the volume of medication that needs to be given to administer a certain amount of drug. Example 4. A prescription for an adult reads Mayclor, 300 milligrams twice daily. Is this prescription safe? And how much medication must be given? Well, let's first start to determine if this is safe. Let's look at the usual dose here. And it says for adults, the maximum that we can give is 375 milligrams 2 times per day. You'll notice in our prescription here, we're giving 300 milligrams twice daily. So that is under the maximum amount, so we would say yes, it is safe to give the medication. Now let's determine the volume of medication we have to give here. To determine that, we look at the drug concentration here. It looks like we have 375 milligrams of actual drug in 5 milliliters of solution. And so in our prescription, we want to give 300 milligrams of the drug, and we want to know how much volume that's going to be. Well, you can see that my variable over on the right hand side, n, is in the denominator, so we're going to flip both of these in the proportion. When I do that, I'm also going to remove the units to make it a little easier to solve. So I'll say 5 over 375 equals n over 300. Now you can see we need to multiply both sides by 300 over 1 to clear out that 300. So I'll say times 300 over 1 on the right times 300 over 1 on the left. The right side is easy. The 300s are going to divide out and leave us with just n over 1, or n. The left side, we are going to need to factor this. And I'm going to go ahead and factor that. So I'd come off of some scratch paper and I'd factor 300 using a factor tree, and I'd factor 375 using a factor tree, and here are the factors that I would get. In the numerator, I'm going to have 2 times 2 times 3, and then 3 5s. In the denominator, I would get 3 and then 3 5s. So let's divide out these common factors. Looks like the 5s are all going to divide out. Also, the 3 is going to divide out. So it looks like we're just left with 4, and that is 4 milliliters, the volume of medication that we're going to need to give to prescribe 300 milligrams of this drug. Now it's time to check your understanding of determining the volume of medication that must be administered to give a certain amount of drug. Hit pause on your video player and answer this guided practice question. When you're done, hit play to see how you did. Question 4. A prescription for adult reads Terracin, 125 milligrams twice daily. Is this prescription safe? And how much medicine must be given? Well, first let's check to see if this prescription is safe. So we're looking at the usual dose here. The usual dose is 250 milligrams administered once every 24 hours, or we can do 300 milligrams administered in divided doses. And if we take a look at our prescription here, it's 125 milligrams twice daily, which means we're dividing this up into doses. So we could give up to 300 milligrams of this medication. Well, 125 milligrams times 2, because we're giving it twice daily, is going to give us 250 milligrams. That is lower than the maximum, so that is safe. So we would say yes, it is safe. Now let's take a look at the volume of medication that must be administered here. Okay, we're trying to give 125 milligrams in one of these doses. So we need to start with our drug concentration from the label, which is 50 milligrams per milliliter. And so we're going to write that per 1 milliliter. That's our drug concentration off the label. And now we want to give 125 milligrams of this drug. So we want to match and put 125 milligrams in the numerator, on the other side of our proportion here. And now we're trying to figure out how many milliliters of medicine to give 125 milligrams of drug. So we're solving for n here. Well, first thing we want to do is get n in the numerator, so I'm going to flip both sides of this proportion. So I have 1 over 50 is equal to n over 125. So now I need to multiply by 125 to get n all by itself. So I multiply by 125 over 1 on the right. Same thing to the left. On the right side, it's easy. 125 is a common factor. It divides out, leaves us with n over 1, which is just n. The left side, we're going to have to take a look at some factoring here. So when I factor the numerator of 125, I'm thinking, well, let's come over here and look at a factor tree. 125, I'm thinking 5 times 25. We'll factor 25 again, since it's composite. So it looks like we're going to get 3 5s in the numerator. 1, 2, 3. 50, let's factor that. Thinking 5 times 10, there's 5 times 10, and then we break 10 down again. So 5 times 2 times 5. Common factors of 5 are going to divide out. Boom, 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 boom. Leave us with 5 halves. Now 5 halves is not going to be a good answer for us. We want to turn this into a mixed number to determine how many milliliters to give. So 5 halves, if we take a look, 2 goes into, and we'll swing around here and we'll say n equals, as a mixed number, 5 halves, 2 goes into 5 2 whole times with 1 left over, so that is 2.5, and that's milliliters. So we would want to administer 2.5 milliliters of this drug to get 125 milligrams in a dose. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.